All right, your question is, what challenges exist in designing cooling systems for high-power electronics?
Hey everybody, Brian. My question is, what challenges do we face for designing cooling systems for higher power electronics? The only real experience I have for this, I actually built my desktop computer when I got out of high school, and I was thinking about the differences between water cooling and air cooling. You probably hear this like all the time whenever, if you're thinking about building a PC, or if you're just thinking about PCs in general. And I wouldn't necessarily say that a lot of these electronics are high power, but it's the highest power that we'll really interface with as domestic consumers without like industrial uses. And what you see that the bottleneck is in that stuff is that if you have like a water-cooled processing unit or graphics unit, it's not going to be that much more efficient than an air-cooled, because at the end of the day, your bottleneck is going to be the actual heat removal from the system. So the only thing that the water changes is that you're now taking the heat from the processor, from the GPU, and taking it to another radiator that's still on your PC, and that's going to be air-cooled. So you're just moving where the air cooling happens. So really the issue is that you have to figure out where your bottleneck is and how to improve. Like, for example, you can have a larger radiator outside the PC if you do want to water cool it, but at the end of the day, that's not really what happens often in like domestic water cooled PCs. So a lot of these like big data centers, what they do is they have a huge bath that the GPUs or the processing units are dipped in, and then they have a loop that's they have cooling towers, and they have all kinds of infrastructure that supports that loop of water cooling, and it's just much more practical for cooling those higher power electronics. But you just have to consider kind of implementing those kinds of that kind of infrastructure along with whatever it is you're doing, and ensure that you're not just moving heat in a different way, but that you're actually increasing efficiency in some way. So yeah, that's what I got.